last thing we got tonight, let's go through the process. I'm going to go ahead and stop this one that's on there of building a forward reversing motor starter. Okay, this is going to have a time delay between forward and reverse. Remember, whenever we flip a motor into reverse, we really need to let the driven machinery slow down to a stop before we go in the other direction. That's critical. Okay, so let's clear what we got inside of here out. Okay, I'm just going to delete it. It's fine. Don't really care. We're going to start this just like we did last week with our good old memory circuit. Okay, we are going to have that 3-wire stop button in the front of the circuit, and then we will build our memory in with our start button, or it'll be our forward button. And then we will have a reverse. We'll show you the process. Okay, so let's drop a stop button in first. Now remember, the electromechanical state of my switches can be logically instantiated in the program in different capacities. So even though I have a normally open red button, if I select a break instruction here, that normally open from an electromechanical state push button will act as a normally closed button. Okay, so I will do my input 03, which is my red button, as a break instruction. So that's going to act as my stop. Okay, now I need a forward push button. Let's make that input 01 because we keep doing that over and over again. That's the green push button. I'm going to put that in as a make instruction. And then I'm just going to take that over and I'm going to turn on my green light, which I happen to know is on Q01. Q is our output coils, okay? Cool. What else we need to make this work? Remember, we talked about it last week. A couple of you were onto it. Is we need some kind of memory or holding auxiliary contact underneath the button that is associated with that output. Okay, so we will just do a virtual auxiliary. We will put a Q01 make instruction. Okay, it activates whenever that Q is activated. We will do a virtual auxiliary contact in parallel with our forward button. Okay, so we got that so far. This is not something that we haven't done before. So let's go ahead and write it over to the PLR. Let's do it. Let's just see what it looks like real quick. Old data in the module will be lost. Don't care. Okay, let's just get us refreshed and back on board. We'll do this step by step. I'm going to run that remotely. Okay, let's jump over to lab board. So we have our holding circuit, okay, that fundamental basis of motor control, and when we hit our stop button, we are breaking that memory. Okay, so basic 3-wire motor control. Okay, let's add in the second piece, and we're going to add it in a little wonky because one of the beauties of these is even if we make mistakes along the journey, we have the ability to modify and fix it. Okay, I'm going to show you the note feature. Okay, so in case you are building something complex and you can't remember what you were working on, you have this note down here at the bottom. So you grab that note, you click the line where you kind of want it to go, and we will do forward. Let's do forward motor starter. Okay, so it's just going to add a line of text in there so we can contextually see what's going on. Okay, now in parallel with that entire forward section, we are going to do our reverse section. So I'm just going to drop a line down and I will do another input below this. This will be IO2. This is going to be our reverse button. Okay, IO2. It's going to be a make instruction. Yeah, and I will take that right over to my reverse coil. We will just do QO2. That is going to be our yellow light. Cool. And just like above it, we need a holding contact that's going to make that work. So I will go down in parallel with the reverse button. I will have a QO2 auxiliary virtual holding contact. Okay, so I'll grab QO2, I will dump it in, and I will make it a make instruction. So you should look something like that so far. Okay, something like that so far. Looks pretty good. Let's write it over to the PLR and let's see where our problems lie, and then we can discuss the next steps. Okay, write it over. Old data in the module will be lost. Don't care. Write is okay. Beautiful. Let's run this puppy. Do I want to read it? Nope. Let's go to lab board. Okay, cool. We have our forward. We are going in the forward direction. Now, if you thought about what we were missing from the other section, hopefully this rings a bell when I push this button. Okay, I have forward and reverse going at the same time. What happens when forward and reverse are actuated at the same time with a motor starter. Well, when you have a forward reverse motor starter, you're flipping the phases, so you're going to get a oops, I blew up situation. Or if you have a proper motor starter, they're going to be mechanically interlocked. But what we used to draw into our diagrams last year, if you remember, was a electrical interlock as well. So let's add an electrical interlock in, so I can't have this situation where forward and reverse are going at the same time. Okay, let's do that. That seems like that would be a smart idea. Okay, so the way this is going to work is they will just be a brake instruction from the opposite side. Okay, so if that one's working, it will make it so we can't get a connection across the other one. What does that look like? Let's grab a output coil Q. So I'm going to drop a Q02 brake instruction on that Q01 forward portion line. Okay, and I'm also going to grab a Q01 brake instruction on the reverse line. Okay, kind of like that, looks like that. And if we need notes, maybe we should probably put a note in there. Okay, this is the reverse motor starter. Okay, let's put that in there so we remember what we were drawing. Okay, that's kind of important. Let's see what that looks like. Write it over. Old data on the module will be lost. Awesome. Good. Right is okay, fantastic. Let's give her a run. Don't want to read the program from the module. This time maybe we'll watch it remotely. Let's watch it remotely. So if I hit I01, give it a second, you can see that pink line complete all the way over to Q01, and I am running. Now I have to kind of hold this so you can see it virtually on here, but I am currently holding the stop button. Okay, so that stops the whole thing. And now if I try to, once it gets gone, okay, if I am in forward and I try to hold the I02 button, that Q01 brake instruction prevents Q02 from getting actuated. Okay, let's see what that looks like on the lab board. Okay, let's jump over. I hit my forward button. Now I have an electrical interlock, so I cannot throw this thing into reverse because that would be a bad situation. Okay, I actually have to stop it, and then I can go in reverse. Okay. If I'm in one direction, I can't go in the other direction. Awesome. Let's stop it there. That seems pretty good. It seems pretty elegant so far. We're getting something done. Okay, but we wanted to add a time delay into these too, because I don't immediately want somebody to stop it and then quickly throw it into forward, because if they did that, they could cause damage to the motor, the equipment, they could cause damage to the driven machinery, it could cause a jump in the system or on the conveyor belt. We want the motor to completely come to a stop and then have the ability to reverse it. So let's do that via some off delay timers. Okay, so I'm going to drop a couple timers in here. I'm going to drop T in parallel with Q01. And I'm going to call that T01, and I'm going to go down to mode 4, which is a off delay timer. And this operational diagram at the bottom will give us an idea how it works. Okay, when that coil gets energized, nothing will happen. Okay, or when it's enabled, but when it drops out. Okay, so once the stop button is pushed and the OTE drops out, okay, I will get an output for a certain amount of time that I set. Okay, remember how those work from last year. So I will set this to 1 second intervals, and I will put a 5-second timer on that. So T01 right there like that. Cool, and I will just connect that up. Sweet. Good. Let's do the same thing underneath it, but let's call it T02. Let's just make it a different timer. Okay, I will set it to mode 4 again for my off delay mode 2, and I will set my interval time to 5 seconds again. That should give this high-end machinery enough time to slow down. Now in the field, that could be any number of times depending on what you're driving, right? It could be anywhere from 5 to maybe 30 seconds depending on what kind of motor you got, what your scenario is. Really depends. Okay, so we will do that same thing on T02 underneath. Now, I do run into a problem here though. I can't stop these things because I'm out of lines of code that I can put in, right? I've got 1, 2, 3 and an output. Okay, all this software allows is 3 inputs and 1 output. I do have a way of cheating around this though, so we'll show you that. What I'm going to do is I'm going to switch these Qs to a memory or internal relay. Okay, it's a virtual relay in every sense of the word. So I will just go to M. It's called a internal memory relay. And I'm going to replace Q01 and Q01, and I will replace Q02 and Q02 with their associated M01 and M02. So Q01 output, I will make that an M01. Q01 auxiliary contact, I will make that an M01. Q02 output, I will make that an M02 output. And Q02 holding auxiliary contact, I will make that an M02. What does that get for me? Well, now I can basically extend this thing down. So I will drop an M01 in here, and I will drop an M02 in here. This gives me an extension of that line. Okay, so I'm basically going to carry it forward down, and I can continue adding inputs and outputs to the activation of these particular devices. Now, since we had integrated the timer in, I'm going to do it like this. I'm going to grab a T for timer 02, and I'm going to drop it in so it will be a break instruction for our M01, which is our forward direction. Okay, so it'll look kind of like that. So what's going to happen is we will not get an output unless TO2 says it's okay. Okay, so let's carry that over, and then we will put Q01 at the end. That is our forward output green light, forward direction, just like that. Okay, and I will have the opposite on the reverse. Okay, so I will grab TO1 as a break instruction. Okay, and I will bring that over to Q02. Okay, sorry if I'm blazing through this kind of fast. Time, it's always time constraints, right? Just like in the real world, manufacturing, go, 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 go. Okay, so what we should have here is we should have a time delay before another direction can be sent, right? So this will be, we'll maybe put a note in. This is the continuation of above code. Cool, that's awesome. Let's delete that one. That's superfluous. Let's give it a write. Old data in the module will be lost. Don't care. Sending it on over. There it is. Okay, we wrote it. Let's give this thing a run, see what we got here. Let's jump over to lab board. So we hit our green light. We are going forward. The motor is being driven forward. We still have our interlock on the bottom. We cannot make that work. Okay, but now we also have this functionality where when I stop, I can't send it in the other direction until that 5-second timer's up, and then I can go in the other direction. So this allows the motor to slow down to a stop, and then I can go in the other direction. Okay, but I can't do it instantaneously. It's going to make that 5-second wait happen, and then we can go. Right, so we have integrated that, but I don't want the operator to think they are absolutely insane that they pushed the button and nothing happened. So let's do an indicating flasher light to show them that, hey, the motor's in cooldown mode. Okay, the motor is coasting to a stop. Okay, so let's break that in real quick as our last step of this little diagram we're working on. Let's stop this bad boy. Okay, and all I'm going to do for this one is I'm going to make a flasher instruction. So let's just drop this in. I'll make a note. Let's call it flasher. Flasher. There you go. I want this to be activated by either of those timers going off, okay? Because those timers going off is going to be the indication that we are in cooldown, right? So I will do TO1, and I can do TO2 in parallel here, because either one of them, I want them to activate this flashing light. I don't want that right there. Let's delete that. Hey, quit it. Hold on. There we go. There it is. And then I'm going to drag those over to a new timer. Okay, so I have TO1 and TO2 make instructions in parallel. I'm going to drag those over to a new timer. I'm going to call it TO3. Okay, just got to keep coming up with new ones. We've got a ton in there. You can't run out very easily. You've got a lot to play with, 31 of them, I believe it is. We'll grab TO3 and we're going to grab that flashing. I think it's 5. Okay, flash timer mode 1. That's perfect. I'm going to set its interval to 0.1 second and its time at 0.1, so it'll flash every 0.1 second. So we'll get 10 of those bad boys a second. Okay, that looks great to me. And I will hit OK. That's our flash mode timer. See what that looks like. What do you think? Look pretty good? Do you see a problem? I might see a problem. Let's see. Let's write it. Let's write it. Sometimes you just need to see a visual of how it's going to work. You can see that, and then we can get our diagnostic. Cool. There we go. I am going to run this program remotely, and let's see what we are looking at. I will go over to lab board. I will hit my start button. I'm moving forward. Looking good. I hit my stop button. Wait, what's the problem? Nothing's happening. I can go in the other direction. Did you catch what we didn't put in? Seems a little weak. Why? Well, I didn't tell it to flash anything. I programmed it in. It was doing it. But I didn't actually make it flash anything. TO3 has to be connected to something. We have to have an output for TO3. Silly me, I forgot it. Okay, so I will have a make instruction on TO3, and I will associate it with an output. Let's make it the red light. I happen to know that's QO3. Okay, so we have, if you're ever building these and something's not working the way it should, go back through logically and see what you might have done wrong. That's why it helps to separate them into sections. So I'll put a comment in here, flashing system. I don't know if I put that in. I think I accidentally deleted it. There you go. And then I will delete this extra line. Okay, so now we should have a flasher. We got to have it doing something. This is supposed to be TO3. I just noticed I hit TO1. Okay, so TO3, while that's flashing, will turn this make instruction on and off, so we get a flashing light. There we go. Whew. You're right, Alexander. That was the weakest flashing I've ever seen. I've seen college football games with more flashing than that. Let's run this bad boy. See what we got now. I think we still have a problem, but we'll find out. Let's hit our button. Looks great. We are moving forward. Let's hit our stop button. We are flashing. That is awesome. Great. Great googly moogly. Okay, we have our flasher built in. We are doing the thing. So now we know, hey, I am stopped. I can flash this bad boy. And we can get that going however we want. Okay, so that is your flashing mechanism associated with it. As long as that thing is in slowdown mode, we can flash it just like that. Okay, and that'll kind of give us our indication that we're switching to the other direction. So if I go forward, I stop, and I hit yellow, I know, okay, I'm flashing, and then when my timer's up, I should go back to yellow, and I'm going in the other direction. Okay, so that is your forward reversing motor starter with a time delay on either side and an indication that that time delay is active via the flasher. Okay, so not a super complicated scenario, but I think you can agree if we had to build this in the field and we had some problems with wiring it and doing some of this other pieces of information, this would be pretty complicated for us to kind of put together. Now, just to reinforce the fact that you can play with this stuff at home, if you need to, I'm gonna drop the link off, and I'm going to show you what this looks like if you were to do this virtually. Okay, so at home, if you choose to play with it and you go run, you're going to have some diagnostic tools in front of you. Okay, it helps if you can link over to the actual unit and do stuff with an actual unit, but if not, you can always play with your inputs and outputs right on here. If I was to activate IO1, for instance, I can see what's going on. I can also monitor my timers on here. Okay, so I've got that forward motor going. If I activate IO3, I can stop it. Okay, and I can probably see my timer counting. See the timer counting on there? Okay, so you can use this as a simulation as well. It's a little bit more difficult when you're seeing it as a simulation. I'm not going to lie to you. It's nice to have the equipment, but just know it's something that you have access to and something that you can work on to get better and build this skill. Cool. That's it.